Hi and welcome to this series of videos for pupils studying OCR 21st Century Science. We're looking at P5, which is electricity, and this is lesson 5. So far we have used the idea of voltage, but now we're going to develop that idea onwards and think of what we mean by potential difference. And potential difference is all about energy in a circuit. So we're going to look at how potential difference means work done to get through a component, and how potential difference means difference in potential energy. So up until now, we've been using the idea of voltage as the push on charges or electrons from a power supply or a battery, and it's that push that gets them to move around the circuit. From here on in, we're going to use the term potential difference. So whenever you hear me talking about potential difference, or PD for short, then I'm referring back to this idea of voltage. But voltage we're now going to ditch and only going to use the word potential difference, or PD, from now on. So let's think about what happens in a circuit. If I have a power supply, and let's say I put in that power supply a bulb and a motor, it could be any components, then what happens is that electrons will be attracted, start drifting through the conductor towards the positive charge at the other side of the power supply. Now we also know that in our old version voltage, the bigger this voltage is, the more the push they get. All right. And that's fine for thinking about this in its earliest form, but we're going to think about what we actually mean by potential difference. And it kind of explains itself. If you think of an electron that's moving down here, when it gets to this side of the bulb, we know that the energy that it's carrying is going to be transferred in the bulb into heat and light, because that's what bulbs do. So when we switch on this circuit, we know that heat and light are going to be given off. Now if energy is being removed from the system and turned into heat and light, which is given out to the room, then that energy's got to come from somewhere. So that energy comes from the energy carried by the charge. So you can think of the power supply as giving the charge or the electrons energy, and when we're measuring the potential difference, what we're really measuring is what is the energy difference in an electron that's here versus an electron that's here. Because when an electron goes into this bulb, it's going to have a certain amount of energy, but that energy is going to be removed in the form of heat and light, so that this one has less energy. So they've got more energy going in, and then as they come out, they've got less energy. And because we know the principle of conservation of energy, that energy has to go somewhere and it's turned into heat and light. So when you're measuring the potential difference, what you're actually measuring is the difference in potential energy of the electrons from one side to the other. That's why it's called potential difference. Maybe it would be better to call it potential energy difference. But it's the difference in energy from the electrons going in to the electrons coming out. So difference in energy, potential energy, either side of a component. So the energy supplied, some of it is given to the bulb, and that bulb converts it into heat and light. And in the motor, that will give out its energy in the form of kinetic energy. It will spin. And again, electrons going into here will have more energy as they go in and less energy when they come out. And if I measure the potential difference by putting a voltmeter in there, what I'm doing is I'm measuring how much energy has been removed from the circuit. if I put a voltmeter across here, then I'm measuring how much energy has been put into the circuit. Now, we don't at this level need to understand what voltage is defined as, but if you think of voltage as energy, then it might well be that if I have a 5-volt power supply here, then the energy difference from here to here is 3 volts, and the energy difference here, or the potential difference, is 2 volts. The 3 and the 2 always add up to what's been given. So think about this idea that this is the energy input to the circuit. So input, and then 3 volts output here, and 2 volts output here. Energy in always matches the total energy out because of the conservation of energy principle. So, just to recap, you measure the voltage of a power supply. That tells you how much energy effectively is being given to the charge. And then when you measure the PD across a component, it tells you how much energy is being removed from the charge. Just going back to my objectives. So we've covered this idea of energy in and energy out, and this idea of potential difference being the potential energy difference. I'm just going to look at this last idea, which is work done. If I take a resistor, and remember all components have resistance, so bulbs, motors, etc. When the electrons are flowing down this wire through the resistor, we know from previous video that a resistor itself is something that's very difficult for the electrons to flow through. And so we can define the potential difference, or the PD. Firstly, we've defined it as the energy lost, but you can also think of it as the amount of work that has to be done by the battery or the power supply. Let's say by the battery. Work done by the battery to push electrons through the component. So, in defining potential difference, we can think of it as this idea, as work done by the battery or the power supply in pushing these electrons through. Remember, electrons don't find it easy to pass through materials, especially resistors. They offer a large amount of resistance to the flow, large amount of opposition to the flow. So to push them through there, then the battery has got to do work. So the battery loses energy because work done is energy. So the cell is continually losing energy in order to push the electrons through, and eventually that energy store will become empty, and at that point it can't push them through and the current stops flowing. Okay, just to recap then, moving on to the idea of voltage now being potential difference. Potential difference measures energy difference between 2 points in a circuit, and we know that we have energy inputs and energy outputs, and the energy input must always match the total energy outputs. And then that further definition is the idea that potential difference can be thought of as the work done by the power supply in pushing the electrons through a particular component. Thanks a lot.